dividing by 2 digits. So, example number 1, we have 150 divided by 12. So, 150 divided by 12. Any problem that is horizontal, you're going to rewrite like this, and then we solve it like a normal problem. But instead of looking at just, say, the 2 and how many times it goes into 1 or 15, we have to look at how many times the entire number goes in. So first, 12 does not go into 1, so we look at 12 into 15. I know 15 divided by 12 is 1. 1 times 12 is 12. Subtract. Bring down the 0. 12 goes into 30. 12, 24. 2 times. 2 times 12 is 24. Subtract. 30 minus 24 is 6. Sorry, I'll show my work. Okay? And I have nothing left to bring down, so I have a remainder of 6/12, which we reduce, always reduce, to 12 and 1/2. And there's my answer for example number 1. So let's move on to example number 2. Okay, 32 divided by 987. So again, I rewrite the problem. 987 divided by 32. Now, here's where we look at one of our tricks. It's not easy for me to say how many times does 32 go into 98. But if I look and I ask myself, how many times does 3 go into 9? I know that 3 goes into 9 3 times. So, get rid of this. So because I know that 3 goes into 9 3 times, I'm going to assume that 32 goes into 98 3 times as well. And I'm going to try it out and see. So 3 times 2 is 6, 3 times 3 is 9, and it does in fact is less than 98. I subtract, I bring down. Now, 32 does not go into 27, so I have to put a 0 in the ones place above the 7. I multiply 0 times 32, I get 0, and I have 27 30 seconds left as my remainder. But I need to find out if I can reduce 27 30 seconds. So to do that, I need to find my factors. So 1 times 27. It's not even, so there's no 2. 3 times 9. 4 doesn't go into 27, 5 doesn't go into 27, 6 doesn't go into 27, 7 doesn't, and 8 doesn't, so these are my only factors. My factors of 32 are 1 times 32, 2 times 16, 3 isn't a factor, but 8 is, 5 is not a factor, 6 is not a factor, 7 isn't a factor. So if I look at my list, 1, 3, 9, and 27, 1, 2, 4, 8, 16, and 32. Other than 1, which doesn't count, they have no common factors. So this then, 30 and 27 30 seconds, is my final answer. Okay. Example 3. A school principal is planning a field trip for 329 students, teachers, and parents. The principal needs to reserve buses for the trip. Each bus can hold 23 passengers. How many buses should the principal reserve? So, how do I solve this? Well, I need to divide the total of numbers of students, parents, and teachers, the number of people going, by how many people can go on each bus. So, we have 329 divided by 23. Okay? Again, we'll use the first digit trick. 23 into 32. If I look at the 2 in the ones place on 23 and the 3 in the ones place on 32, I know that 2 goes into 3 once. So I'm going to assume that 23 goes into 32 once. So 23 into 32 once, multiply. 1 times 23 is 23. Subtract. 12 minus 3 is 9. 2 minus 2 is 0. Bring down the 9. And now I have 99. Well, again, I really have no idea how many times 23 goes into 99. But I do know that 2 goes into 9 4 times. So I'm going to use my first digit to estimate. So 4 times 3 is 12. Carry the 1. 4 times 2 is 8, plus the 1 is 9. And 9 minus 2 is 7. So now I have a remainder of 7. And the reason that I have a remainder is because these are actual people going on a bus. So I have filled 14 whole buses. But I have 7 more people that are going on that trip. So I need to get a bus for them because they can't ride on the roof. So I have 14 full buses plus 1 partial bus, means it's not quite full, means I need a total of 15 buses for that trip. Okay? Okay, go ahead and go into your lesson practice. Double check, it may go on to the next page. I think it goes all the way through P. So double check and we'll see you in the morning.